All right, welcome everybody. Let's do this. So, homework number 10 review. What I'll do is I'll just start over. Even though we did this question in class, I'll just kind of go through it again. So, let's see. Pregunta número uno. Okay. It says, for the function f of x equals x cubed minus x minus 1, the table of solutions is displayed below. So what this is basically saying that like if I plug in 1 in here, it gives us negative 1. If we plug in 1.1, we get negative 0.77 and so on. So find an approximation for which there must be a solution for the function. So when does a solution occur? Right? When does a solution occur? It's when you have, let's say, these 2 points, right? And when one of the second the line, the continuous function, if it is continuous, if the continuous function crosses the x-axis, that's a solution. And remember, another word for solution is the zero, the x-intercepts, the roots. Okay, so you just have to be solid with that terminology. Okay, and when will this happen? Notice that for every point, you have an x and a y, an x and a y. But another way of saying x comma y, you can say x comma f of x, okay? So let's take a look at the f of x, right? Remember, the y and f of x are the same. Notice that if you're a point and you're above, right, you're above the x-axis, then your f of x has to be positive. Okay, and that's what this means. This is the algebraic notation that your y value is above the x-axis. Your y values are positive. Okay, well, this is an x comma y, and so this is an x comma f of x. Notice that for a point below the x-axis, the y values, or the f of x values here, f of x has to be less than 0, right? This implies that you're below the x-axis, okay? So if you have a continuous function, notice that one of the values has to be positive, and then one of the values is negative. The second, you have a point that goes from negative to positive, or positive to negative, then a solution or one of these will happen. And that's what we need to look at over here, okay? Here, when does the sign change? Okay, notice that it goes negative, 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 and notice what does that mean for the graph? Whatever this graph is, okay, where are these points over here? These points are below the x-axis, and then notice that from 1.3 to 1.4, the value starts becoming above. These values are above the x-axis. So there has to be a solution somewhere between 1.3 and 1.4 because it changes from negative to positive, and you know that the function is continuous, okay? Because this function is continuous, you know it has to eventually hit it, okay? And that is the solution for this one, that's between here. So what's a proper way of justifying it? You could say a solution occurs on the interval 1.3 to 1.4. Okay, and that would be a proper justification. Okie dokie. Let's look at the next one over here. So f of number 2. So here, this question, what is it saying? It's saying find the value of c guaranteed by the intermediate value theorem of f of x equals x squared plus 4x minus 13 from the interval, on the interval from 0 to 4 such that f of c equals 8. Okay, for this question, it's very similar to the question I did in part 1, but what this question is asking, and if you want, put on the subtitles and write this question down. What this question is asking, what is the x value that when you plug it in here, it gives you 8? And notice that that x value, let's call that x value c, right? That value of c is there one between 0 and 4? That's the question, okay? So how do we use the intermediate value theorem to show that one must exist? And what is it? It's saying we have to find that value. Okay, so anytime you see intermediate value theorem or you think to use it, always, always, always show the justifications, okay? So what's the first justification? We have to show that is this function continuous? And f of x is continuous, and give a justification why, because all polynomials are continuous, okay? So you have continuity, right? So let's look at the next part. What is the next part? Is f of a not equal to f of b? So here we need to find out, and remember, if I have 0 to 4, this is our a and this is our b, okay? I'm sorry, I should have wrote that here, but if we have 0, yeah, this is our a and this is our b. So here we need to find f of 0 and we need to find f of 4. What I want you to do without using the calculator, find out what this is, okay? Pause the video and take your time. Plug in 0 into this and plug in 4 into that, right? And you should get negative 13 and 19. And notice that f of 0 does not equal f of 4. Okay, happy face, right? So far the first two conditions are good because these two values don't, they're not equal. Now what's the third condition we need to show? We need to show that, notice that we need to show that f of a is less than f of b, which is, I'm sorry, this one should be c, which is less than f of b, okay? So here, what is your f of a? Your f of a is 0, so f of 0 less than f of c, which is less than f of 4. And is this inequality true? Is it true? Okay. Well, let's see, what's f of 0? It's negative 13. What's f of c? It's 8, okay? And what's the other one? 19. Now, is this inequality true? Is 8 greater than 13, but less than 19? It's true, okay? So what does that mean? That means there has to be some number between 0 and 4 such that when I plug that number in, it gives us 8. Now the question is, how do you find that value? So what we need to do is, which isn't too bad, you just take this function of x squared plus 4x minus 13, and the way you algebraically say, hey, what's the number that when I plug it in here, it gives me 8, you just make it equal to 8. And now you solve for x. But in this idea, let's just substitute x with c. So it's just c squared plus 4c minus 13 equals 8. What I want you to do is pause the video and try and figure it out, okay? So let's see, so c squared, what do you do? So c squared plus 4c minus 21 equals 0 because you're doing minus 8 minus 8. Then you factor this, so it's, what is it, c plus 7, c minus 3 equals 0. And then notice that you have c plus 7 equals 0, c minus 3 equals 0. So I don't want to write on the next page. So here, notice that c is equal to minus 7, c is equal to positive 3. And yeah, these are the two values of c that give us 8. But remember, we're in the interval from 0 to 4. So negative 7 is not in between 0 and 4. So we cross that one out. And c equals 3, okay? And yeah, great. So that was question 2. And you see, if you just did this, and I saw a lot of you do this today, you just started doing this, which was nice, but you're not allowed to do this unless you check the intermediate value theorem. This is not a proper justification because you don't know if this is true. You don't know if it's true unless you show this. Okay, even though it is true, right? We want to be ball players in calculus. So to be a ball player in calculus, you got to show the proper justification. Okay, so let's look at question number 3. Show that g of x is equal show that g of x is equal to 2x cubed minus 5x squared minus 10x plus 5 has a root somewhere within the interval of -1 and 2. The second you see the word root, you have to think back to this little picture, right? So it's saying from -1 to 2, is there a point below the x-axis or above the x-axis? Like, are there 2 points that are above and below the x-axis, and is it continuous? Okay, so here we can use, let's see if the intermediate value theorem works. So let's check condition 1, condition 2, condition 3. Okay, so here let's see, is it continuous? So let's see, g of x is continuous because all polynomials are continuous. Okay. Let's see the next one. Now we need to plug in this one. So f of -1 and f of 2. Let's see if these two are not equal to each other. So take your time and figure out what is, oh wait, I'm sorry. This is not f. I keep doing that. It's g, right? This is the name of the function. So what's g of -1 and what's g of 2? Okay, take your time. So let's say you pause the video and you came back. So g of -1 should be 8, and this should be -19. Now let's show the inequality. By IVT, right? There exists a value of c such that g of c equals 0 because g of -1 is greater than 0 and g of 2 is less than 0. And that's the idea here. Notice that visually what's happening here. You have this point over here. This point is -1 comma 8. And notice this point, is it above or below the x-axis? This is somewhere over here, it's above. What about this point? 2, -19, it's below. And what do you know about this function? It's continuous, so there has to be a value of c such that g of c is 0, that it intersects and the y value is 0, okay? What that c value is, we could find out, but that's not what the question's asking. It's just saying, show that a root has to be there, and a root has to be there because of the intermediate value theorem, and we checked all 3 conditions, okay? All right. What I'll do is oh wow, that was 13 minutes. Okay, I'll pause the video and I'll do the next questions.